Hello. This time we will solve this question, which is the 2D resultant force, resultant moment question using vector analysis. If we're going to do vector analysis, first, recognize first, the picture the question gave us is already the free body diagram, so we can use it straight away. Then, to set up the axis, again, with the vector analysis, we need specific axis. So there is no twisting, there must be a rule for it. Then, if we assign x and y, in this case, to the right hand side positive and upward positive, the z-axis and the moment rotation will be forced upon us. First rule is the right hand rule. In your picture, because we're going to flip it left and right, this will look like my left hand, but in fact it's my right hand rule. This is right hand rule. Your thumb is x, your index is y, and your middle finger is z. Since we set up x, y like this, so this is x, this is y upwards, and then the z pointing towards me is the positive one. Then the second right hand rule is the right hand rule for moment. It said that a moment rotating about an axis, right? In this case, we're talking about moment about z axis. So you think your thumb as your as your z this time, which is the rotation the axis for moment rotation. In this case, going this way, and then notice what happened to your finger when you make a fist. From here, it rotates this way, which means anti-clockwise positive here. Therefore, it will go this way, anti-clockwise positive. Now, since we set up the first rule, then let's notice this is important, the definition. We need to put this in vector. So, I will call 8 kilonewton F1, and I will call the 20 kilonewton F2. Then I will call the distance measured from O to F1 R1, and the distance measured from O to F2 R2. Okay, so once we set the definition, then we can isolate them and tell the others what it means. Then F1, because it's 2D, it will have two components, but we will use the third component just in case. Then F1 is equal to, the first component, 8, is 8 cosine 30 degree. If you use the calculator, 8 cosine 30 degree is 6.928, and then the y direction is 8 sine theta, which is sine 30 degree, which is 4, and then no, it's nothing inside, 0 kilonewton. Then we also have R1. R1 is equal to, again, it's measured from O to that point, from the point where the force was acting on. In the x direction, it's from here to here, 1.5. And then in the y direction, it's from here to here, 2.5 meters, then 0. Okay? Right? If we do the same way with F2 for this 20, right? Then we can make note up here, then we can create this up for something else. Okay? So we have F1. Let me design the space. F1 is equal to 6.92840 kilonewton, and R1 is 1.5 2.50 meter, and then F2 will be equal to first component is 20 cosine 45 going to the left hand side, therefore a negative of 14.14. In the y direction is 20 sine 45 vertically, so but it's going upwards, therefore it's positive of 14.14 and nothing inside, kilonewton, and R2 is equal to, again measure from point O to 20. So from here to here, in the X is exactly 2.0. In the Y is from here up here 0.5. And then 0 meter. Okay. Now next step, we'll do the combination, the resultant force of F1 and F2, which I need this space, so I will clear this out, and then we can continue. So once we identify the forces and the distances in the term of vectors, now we could use the vector operation to calculate everything. We don't have to consider the sign convention plus minus until almost at the end stage of the answer. So let's see. Start off with, if we find the resultant force or the summation of all force sigma F, then the force is equal to F1 plus F2. Well, using the vector operation, the first one will combine with the first one, right? The first slot and the first slot, X and X basically. So that one combined with that one is equal to minus 7.212 kilonewton. Second slot 4 and 14.14 become 18.14, and then of course last slot is 0. Now that is actually the answer already. Well, almost is the answer, but not in the right form yet. So we have to interpret it a little bit further, right? Start off with the 7. In the X, minus 7 is going from the right to the left hand side, of course opposite to, because it's opposite to the X direction we assume. So 7.212 kilonewton. In the Y, positive, therefore upwards of 18.14 kilonewton. Make the rectangle, and then we have the resultant force going there of sigma F. Now, using Pythagoras, we get the magnitude of sigma F is equal to 7.212 square plus 18.14 square, overall inside the square root, which is equal to 19.52. Positive, of course, is in kilonewtons. The direction is up and left. Now, again, this is not quite detailed enough, not quite specific enough. So we assign the angle of theta to the x-axis, to the vertical, to the horizontal axis. And that theta can be calculated using a tangent of that side divided by that side, which means it is 18.14 divided by 7.212, which is equal to 68.32 degrees. Okay, so let's make notes somewhere, because we're gonna have to use this space to calculate the moment and then answer them together, right? So where should I note it? Can I note it here? Sigma F is equal to 19.52 kilonewton. That angle is 68.32 degrees. Okay, So now I will get rid of this so that we can start with the moment calculation. Okay, now it's time to calculate the moment. With the vector analysis, the moment cannot be calculated as one equation of the summation in one go. We have to calculate the moment separately first. Therefore, let's start off with the first moment. I will call the moment about point O caused by F1 MO1, the vector of MO1. Okay, then the way we calculate, we use the cos operation. So M subscript O by force 1 as a vector is equal to R1 cos F1. Of course, we have identified R1 here and we have identified F1 here. Next one, the cos operation, there are quite a few ways to solve for the cos operation. You can use any method you like. I am more familiar with this one, so I shall use this one. I set up the metric of I, J, K and then repeat I and J again. Start off with the distance 1.5, 2.5, right? List T 0, 1.5 and then repeat 2.5, the last two. Then I put in Fx 1, of course, Fy 1, Fz 1, repeat Fx, and then Fy. The next step is to cross it down, then time positive, cross it up, then time a negative 1, right? There we are. This line here is 0, this line here is 0, that line here is the first one that we use, so that becomes 6 plus k, right, time k, right, and then because this one is also exists, so it's 6 times 2.5 k, but because it's cos up, so it has to time minus, so it becomes that one. The two combined, this 2.5, then is equal to minus 11.32 k. In this case, is in fact equal to minus 11.32. The unit of all force is kilonewton, of distance is meter. Therefore, the unit here is kilonewton meter k. You can put it in the vector form you want, 0, 0, minus 11.32. But for the note, I think this is enough. So I will make note here, MO1 is equal to minus 11.32 kilonewton meter in the z direction, around z axis I should say. Okay, so because I will need to calculate this one for moment caused by F2, which I need this space, so I will remove this one. Now we have the moment about point O causing by F1. We need another one, so the moment about O caused by F2, we will call it MO2. Now, therefore, MO2 will equal to 2 cos F2. Right? Again, I will set up the IJK system because that is how I am familiar with the calculation. So put the distance in first, 2, 0.5, 0, repeat 2 and 0.5. Then the force, Fx2 and Fy2, 0, and then Fx again, and then Fy. Okay. Now, the first cross downward 0, second cross downward 0 again. Then we have that one. That one is 28.28 K. downward positive, so we change nothing. Then we have that one going up, negative of, don't forget times up is a negative 1, then minus 14.14 times 0.5 K. That one worked out to be 35.35. Now, the unit is kilonewton and meter, then kilonewton meter in the K direction, right? So now we have the two moments to combine. So if I, rather than putting a note here, I just combine it straight away because it's also K and K is a simple calculation already. I don't need to set up the metric again. So just to be a quick one, then the sigma moment about point O, which is of course that one combined with that one. That one is positive, that one is negative. Combine up, it becomes 24.03 kilonewton meter K positive. Okay, so now we have our answer, that one and that one. That one, well, I don't have to put it into the vector form or scalar form because I can answer it from here straight away, right? So what I have to do now is remove that part so that I can write up the answer properly. Okay, now after all this calculation, in fact, we have only two answers here. One is the resultant force and one is resultant moment. So let's do this. The first answer will be, I will put in the resultant force for now. The resultant force is 19.52 kilonewton up and leftward, with of course we need to specify the angle with an angle of 68.32 degree to horizon. Right, that is our first answer. Our second answer is the resultant moment. Misspelled. Resultant moment is 24.03 kilonewton meter. Positive actually means we assume the correct direction for resultant force, which is anti-clockwise. And then that will be our answer. And this is how we solve for resultant force, resultant moment for this question using vector analysis. And that is done. Thank you.